Assalamu alaikum. Welcome to chapter 5, metal casting processes and equipment. Before I go on, chapter 2 in the Kalpakjian book is on mechanical behavior of materials. It is not included because it has already been covered in the earlier course on material science, right? Mechanical behavior of materials. Chapter 3 is a structure and manufacturing properties of metals. It is also not included this time because again it is already covered in the earlier course on material science. Whenever good textbooks are written, then they do this, that the book is actually about manufacturing processes. But chapter 2 and chapter 3 are about structure and properties and behavior of materials, because that is needed in manufacturing definitely. That is why in our university and in majority of universities around the world, a prerequisite for the manufacturing course is material science, because if we don't know about materials, then we can't do almost any manufacturing. So just to make the book complete, that you want to learn something about manufacturing, and many times material properties and other things are required. So they include the 2 chapters here, though it is not a book on material science, right? So chapter 1 was introduction, the general introduction and coverage of the whole course, and chapter 2 and 3 are material science. So you must know what is there in chapter 2 and 3, but that is already covered in a previous course. Chapter 4 has a big name: surfaces, tribology, dimensional characteristics, inspection, product quality assurance. This we will cover in this course, but according to my plan, it will be covered later. The book is written by some authors and they have a certain view of how they will proceed with the course. I feel that we should start with basic manufacturing processes first, and that is why chapter 5, which is on casting, it's a huge big method, and there will be lots of sub methods and things inside the chapter. So we will cover directly then a chapter which is on basic manufacturing process of casting. Once we have done some manufacturing, then we can go back to how do we improve surfaces, what is tribology, how do we inspect, how do we do quality assurance. So to me, unless we have done some manufacturing, we have produced or manufactured some products, then their surface and quality and those things cannot come unless they have been manufactured. So to me, the natural scheme of things is that we go to 1 or 2 basic fundamental chapters of manufacturing themselves, and then we go back to chapter 4, which is like once we have produced a casting, then how do you improve the surface and how do you inspect it and so on. Okay, so that is why I have these few slides. Chapter 1 was introduction, chapter 2 and 3 are about material properties and so on, which is covered in an earlier course. Chapter 4 is on surfaces and quality control, which we will cover later. So now, with this background information, let us go into chapter 5, which is metal casting of metals. I am just showing you a picture, not from the book, but general picture of the casting process, right? You melt the metal in some furnace, you get this metal into some container, and you have prepared certain molds or dies, and you pour the molten metal into the molds and dies. And once this pouring process is complete, then there is the process of cooling and solidification and so on. And once it is solidified, then the molds will be opened or whatever, and the material will be in the shape that you want it to be in. So that is why, if you remember the introduction chapter, that 1-page diagram of classification of all manufacturing, right? Then manufacturing was divided into processes and into assembly operations. And in shaping processes, the first one was solidification, right? So casting belongs directly there, melting and solidification. Manufacturing is one of the earliest metal shaping techniques known to humans. When we say one of the earliest, it does not mean the earliest. I mean, right? Forging, like hammering and so on, using rocks to shape some metal, was the earliest, but one of the earliest. So thousands of years ago, casting was already known to human beings. If you remember your Surah Kahf, right, then Hadid is mentioned, and casting and plating are mentioned, and so on. Now, virtually nothing moves, turns, rolls, or flies without the benefit of cast metal products, which means that almost all types of products in the world can be made by castings. The metal casting industry plays a key role in all the major sectors of our economy. If, of course, almost every type of machine, from a cycle to a car to an aeroplane, has lots and lots of parts which are made of casting, then casting is a major role player in the economy. And there are castings in locomotives, which are trains and so on, cars, trucks, aircraft, office buildings, factories, schools, homes. So almost every walk of life there is casting. Now don't read further, please, right? This I keep on requesting you from time to time, that if I say don't read further, then you don't read further, because we will feel very strongly that you guys are really good. You have a very good educational background in until high school, Sanviya, science, math, this, that. Then in engineering, you already have done 2 to 3 years. So you have a lot of science and engineering background. Therefore, if you just think a little, then you can already start replying. So if I ask you, please define casting, please define casting, right? Then all of you, most probably, if I was in a class, there would be several answers. But if you have stopped my video and then started, think yourself and come up with an answer, you would have already said, the doctor, you have defined it very recently. You have already defined it in chapter 1. Whenever a metal is melted and the molten metal is poured into a die or a mold, and after cooling we get the product, then this is casting. So yes, you are very right. This is casting, and all of you most probably have got the correct answer. But just to define it more correctly, we go to this definition. Casting is a process in which molten metal flows into a mold where it solidifies in the shape of the mold cavity. So this is the definition. And the part produced is also called casting. So you see, this is just English language for you. The process, the manufacturing technique, is casting. And after casting, what you get, the product, is also called casting. So sometimes that is there, that the manufacturing process is known as casting, and the product of this manufacturing process is also called casting. Parts made by casting, two big things: you can produce big parts and you can produce small parts. So that is why it is such a universal and popular method, because some methods you can do only big parts, some methods you can do only small parts, but by casting you can do very big to very small. Very big ones: engine blocks and heads for automotive vehicles, cars, trucks, and so on; wood burning stoves, machine frames, railway wheels, pipes, church bells, and so on. Small parts: dental crowns. Remember, right? If your tooth is partially broken and they have to put a small metal part on top of it, that is a small thing. Jewelry, small statues, frying pans, right? So from very big engine blocks and heads to small things like dental crowns. So it means that casting is a very versatile method by which, in terms of size, you can go from very small castings to very big castings. Here it is one of those, again, very, very useful and tables or one page where you have a lot of information. So if you see the heading, typical applications for castings and characteristics of castings. So here, type of alloy, application, castability, how easy it is to cast, weldability, how easy it is to weld, machinability, how easy it is to machine. So this is brilliant. It means that this is not only for this chapter. If you read all of this, then this column tells you information from the casting chapter, that aluminum, copper, this, that, how easy it is to cast. But this is the another chapter on welding, that how easy it is to weld. And this is the chapter on material removal or machining, how easy it is to machine. So this one page can be a very, very great basic source for mechanical engineers and for manufacturing people. So now, types of alloys. If you remember from material science, there can be pure metal and there can be an alloy. There can be iron and there can be steel and there can be cast iron. They are all iron based. There could be pure aluminum, there could be aluminum alloys. So metal or alloy of aluminum, copper, gray iron, magnesium, malleable iron, nickel, nodular iron, steel, other types of steel, white iron, zinc. So all of these. What are the applications? Aluminum alloys, pistons, clutch housings and so on. Copper alloys, pumps, valves and so on. Gray iron, engine blocks and so forth. Right? So please go through this. Go through this. It is a great piece of information that most of the famous alloys, right? Normal steels, carbon and low alloy steels. Specialty high alloy steels, isn't it? And gray and cast iron, right? So all of these, what are the applications? Now E here is excellent, G is good, F is fair, VP is very poor, D is difficult. So E means excellent. So aluminum alloys from a casting viewpoint, good to excellent. Copper, right? Fair to good, but not excellent. Gray iron, excellent, because gray and cast iron are made for casting. Magnesium, there's that. Steels, normal steels, fair. Normal steels, it is fair, not very, very high, right? Special alloy steels, fair. Zinc alloys, excellent. And then this is for welding and machining. This you can study later on. So this, if you go to the welding chapter, and this when you go to the material removal chapter, you can still refer back to this table 5.3. Now, one passing thing, in your university here, all engineering students do workshop 1, right? All engineering students, civil, mechanical, electrical, chemical, petroleum, all. So, and machine shop 1, you go to the machine shop, you go to the workshop, and you do lathe machines, right? Turning, this, that. You do milling machine, you do surface grinding, you do drilling, you do shaping, you do hand tools. So workshop 1 is all basic machining. Mechanical engineering students even do workshop 2, where they make bigger products, but many other engineering students don't do workshop 2. So mechanical do workshop 1 plus workshop 2. So they have done the material removal or the machining operations to a very large extent. But all engineering students have done workshop 1. So therefore, to cover more manufacturing in one course, in this course of manufacturing processes, we do not include material removal or machining as a separate chapter, because though we have not taught you as a theoretical course and so on, but all of you have done a full 1 semester of workshop practice, which is machining, right? So therefore, this very important portion of manufacturing processes is not covered in the theoretical part of the course, but it is very much covered in the practical part, right? So why I remembered that? Because if you want to see machinability, how easy it is to machine, then you have already done that and so forth. Welding, of course, we will cover hopefully later on. So this is one of those rare, very good 1-page documents which can be a source of a lot of information for engineers.